All right, guys, sorry I got cut off there. So what we're going to have here is we're going to continue. With this problem, and now we've got this 50 Newton air force. So what we have to do is we have to add that to our free body diagram. So our free body diagram is already pretty much done. We've got our normal and our gravitational force, our applied force to the right, and then our motion to the right. And now we've got this air resistance force. It works against motion, so air resistance, just like air friction, works against the way we're moving. So we're moving to the right, so drag works to the left. So now what we're going to do is we're going to write the sum of the forces acting on the skater. So the sum of the forces in the y direction, we just have our normal and our gravitational. So normal and gravitational are balanced because we're not accelerating up or down. So the sum of our forces in the y direction is 0. And then the sum of our forces in the x is going to be our applied force and our drag force. So the sum of our forces is our applied force minus our drag force. And we know the size of our drag force is 50 newtons. So the sum of our forces is Fa minus Ft, and that equals our mass times our acceleration. Mass times acceleration, so we have now the sum of our forces is our mass times our acceleration. It's Newton's second law. So let's go ahead and figure this out. So if our applied force is 50 newtons, then what would we do? We'd substitute this into this. So 50 minus our drag force, which was 50 newtons, would be mass times acceleration. To solve for that, we divide this by mass, since we know his mass is 25, and we're left with acceleration equals our forces divided by mass. So if we plug in a 50 here, so we've got our applied force of 50 minus our drag force of, let's see here, we left it off here. So our applied force is 50, our drag force is 50, so if we have an acceleration here, it would be 0 meters per second squared. So this doesn't fit in with this. I don't know why this is here. My apologies. So 50 minus 50 divided by 25, so 0 over 25 is going to be 0 all the time. So if we have an applied force of 50 newtons, then our acceleration is 0. If we apply a force of 100 newtons, so 100 minus 50, so what do we got? 50 there over 25. What's our acceleration going to be? 50 divided by 25, it's 2 meters per second squared. And then we have our applied force of 200 newtons. So we plug a 200 in here. 200 minus 50 is 150. 150 divided by 25 gives me 6. And my answer is 6 meters per second squared. So this changes how we move. If this drag force wasn't here, then we'd have a greater acceleration. We wouldn't have to factor this in. It would just be 100 over 25, not 100 minus 50. So we look here, and if it's our 100 newtons and we're going back to when we didn't have drag, it would be 4 meters per second squared. But we do have drag now, so it slows us down. And that makes sense. Friction is going to slow us down. All right, next one we have is a box of mass m hanging by a string from the ceiling of an elevator. So let's draw a free body diagram. So we automatically know we're hanging, so we've got a downward force of gravity and an upward force of tension. So here's our free body diagram. Force of tension is going up and our gravitational force is going down. We don't know what if we're moving or what yet. And it shows that we are moving upward. So what is the tension in the string if we're accelerating upward? So that's what we're looking for. We're looking for our force of tension. So the sum of our forces is our force of tension minus our force of gravity because they're in a different direction. And we need to figure out mass, what that means. So we're looking for Ft. So Ft is equal to our mass times our acceleration plus our force of gravity. All we did was add this guy to both sides, and we moved him over here. So we added to both sides. There he is. And now we're going to calculate. So now what we have to do is we actually have to do the algebra behind it, or the math behind it, and calculate it. So let's take a look here. So we're going to calculate the tension in the string if the mass of the box is 5 kilograms and the upward acceleration of the elevator is 1.4 meters per second squared. So we plug in, we've got, let's see, we've got our mass is 5 kilograms. We've got an upward acceleration of 1.4. So let's take a look. And the force of gravity. Let's see here. So our mass is 5 kilograms. Our acceleration is 1.4 meters per second squared. So we know that force of gravity is the weight, and that's equal to mass times gravity. So our mass here is going to be constant. We have a gravity which is 9.8, and we have an acceleration which is 1.4. So we plug in 5 for our mass, 1.4, and then roughly 9.8, 10 for our gravitational force. 5 times 1.4 plus 5 times 10 gives me 57 newtons. So our force of tension upward is 57 newtons. Now let's see. And I think that this one, let me make sure that this was not included. Yeah, and this one's not even included. So when you get to 4.13, when you get to this acceleration, you are done. So what I need for you to do is I need to make sure that you've completed through page 70. Let me see here. Let's go ahead and do what you can through page 79. We'll talk about this in class some. And I also need you to make sure that you have done the problems on, or just the little scenarios on CW third law. So starting on page 72 in our yellow book, numbers 9 through the beginning of Newton's second law of motion on 74. So 72 through 74, and then through 78. And we'll talk about these in class. And if there's anything else, make sure you let me know. Thanks a lot.